Let's take a look at this chart here that shows us determining epicenters. Remember, your epicenter is on the surface, directly above the focus, which is underground, which is where the earthquake starts. All right? So we want to be able to determine where an earthquake started. First of all, you know that we have to have readings from 3 seismograph centers to be able to determine the epicenter. That is an important concept that you need to know. Sometimes we have graphs like this, and remember, it has our P waves and our S waves here. And which waves are going to get there the soonest? Our P waves arrive first. Then we have our secondary waves, which are slower. What are the waves that cause the most damage during an earthquake? That's our surface waves that we talked about. They cause the most damage. So if we look at this chart right here, we can see, let's see if I put this up a little bit, if it's better or worse for you to focus in on. If you look at this chart right here, you can see that at the bottom here is our epicenter distance in kilometers. Goes from 0 to 10,000 kilometers. This is our travel time in minutes. Goes from 0 to 23 minutes. Please note that which waves get there the quickest? It's our primary waves. Our secondary waves arrive next. Now, as we have learned, the difference between the P wave arrival time minus the S wave arrival time, okay, is important for us to be able to determine where an epicenter is. So we may be able to say, for example, if the seismic wave arrival time difference is 7 minutes, then how far away is the epicenter? So if my difference equals 7 minutes, so that would be my difference between here and here. If that equals 7 minutes, then I can determine my epicenter distance. All right? So I need to find a spot between here and here that is 7 apart. So the first thing that I'm going to want to do is kind of look at areas that start at direct points, so I can then kind of determine. So I have 1, 2, 3, 4, 5, 6. That's more than 7. So I have to come down. This one starts right here, and I've got 1, 2, 3, 4, 5, 6, 7. A little more than 7 there. So that's not going to work there. Let's try here. 1, 2, 3, 4, 5, 6. A little more than 7 there. Let's see. This one starts at the beginning. 1, 2, 3, 4, 5, 6. It's got to be up here. 1, 2, 3, 4, 5, 6. Nope, don't have any there. 1, 2, 3, 4, 5, 6. Nope. So let's see. We've got one that starts here. 1, 2, 3, 4, 5, 6, 7. All right, there we go. I got one that starts here and one that ends here. And if I count down, 1, 2, 3, 4, 5, 6, 7. So what I'm going to need to do is then to continue all the way down. And then that would mean my epicenter was at 5,500 kilometers. Okay? So that's how you determine that there, based on the differences. Another thing that they might be able to ask you on this is that what is the difference in arrival time, and then they give you a epicenter. So they could say, what is the difference in arrival time at 7,000 kilometers. And so this is our arrival time between our P and our S waves, right? So let's take a look at our chart here. Let's go at 7,000. We're going to come all the way up. We're going to hit our wave there, and we're going to come over here. So I'm going to say that that's probably, what, about 1075? Not quite at the mark. That's my P wave. I'm going to continue to come all the way up here and over. Whoop, not a very straight line there, Mrs. Rini. Over. And I'm going to say that that is about 18.75. So the difference in my P and S wave arrival time at 7,000 kilometers is 8 minutes. The difference between here and here. All right? So I can calculate that also. You need to be able to look at a graph and answer both of these kind of questions on your test that you're going to be having. So make sure you kind of review this over and understand what's going on this graph.